Good evening and welcome to another Biology Live with Mr. Wilson. This evening we're going to be looking at circulation. I do hope that wherever you are in the world, you are doing well. I am very happy to have those who are from other countries with us. And once you would have joined and you're from some other island rather other than Jamaica, I would love for you to say your island because we have a section of the show that would deal with that type of a thing where we want to know what's happening in your locality as a cultural exchange for us is very important. Now, I'm seeing persons logging on. At this point, I ask that you invite your friends on over. Good afternoon, good evening, everyone. Invite your friends on over. It's a Sunday evening. In most cases, persons are home. We're going to be having a wonderful show. Uh, I must say, for the early part of this show, a group out of Trinidad and Tobago subscribed to the channel this morning. It's a group, and I prefer not to say what's the name of the group. The mission of this group is to make Trinidad and Tobago better. I must say, I am very happy that I can partner with you in making Trinidad and Tobago better as we are putting out content that we do hope that the students of the Caribbean will benefit and the passes for the external exams, they will get better. Again, I tend to talk a lot about Trinidad and Tobago and Guyana because we're always having visitors to the channel from Trinidad and Tobago, and we're always having visitors from Guyana. Might I also say that we've had a lot of persons this weekend for some reason from the USA, and we want to say thank you for visiting the channel. And we want to remind everyone once you are watching the videos, please watch the videos to the end. We did recommend for persons who are too busy because of the kids, because of your shore, because you really don't like to stay one place, just go to the channel itself, go to playlists and select your favorite playlist. Click your playlist and you can listen to the videos while you do whatever you are doing. But we are really, really happy to be here serving you. We are really, really happy to be here another Sunday evening. We had a great show on Friday. We had a Guyanese in the house on Friday, and that was really a wonderful lineup. It started the cultural exchange was really rich as to what's happening in Guyana versus what's happening in Jamaica. I had the opportunity just before this show to listen to last week's Sunday show. And of course, to me, in my opinion, it was a wonderful show because it had me listening for a hour and something. And I was doing some work and I was listening to the show. One of the reasons I listened to the show to ensure that I get better as I go along. And if there is something that I needed to follow up on from the show, I can follow up in order to give the response in the show to come. Now, a whole lot we have lined up for this evening. I do hope that you did study. I listened to the show and I realized that we covered way more than I expected us to cover in that show. It was such a great show. I really didn't want to leave you, like I said in the last of that show. There are some persons who are concerned about the show and might think that we are covering just for biology. Might I say, I look very closely at the syllabus and I'll be reading from the syllabus just before I get into the show. I'll be looking at both syllabus and I'll tell you what is it that is expected to be covered. Now, I have in my hand here, usually I have some notes for the show, what I have planned for the show, and what exactly I am supposed to cover from the syllabus. So all that is here in my hand, and also next week's show is already planned and it's here in my hand. So next week, Sunday, we are going to be covering specific objective 4.5 and 4.6 from the syllabus. Now, next week, Sunday, we should be able to bring an end to circulation in animals for both HSB and biology. We were able to put out another animation yesterday. We did an animation today, and we hope that you are now having a better understanding as to what happens as blood circulates or blood passes through the heart. And we do hope that now you have a better understanding as to what happens as the blood makes its way through the heart twice, the double circulation. We do hope that you are now better at that. We're going to continue to put out more animation. I'm going to be doing an animation for blood clotting because that is something that is giving students trouble. So I'm going to do something real that you can actually see what happens when the blood clots or when you get a cut, whatever happened, the inflammation response. We want to, I'm also going to be doing a video to show you what happens during systole and diastole, animation that is. So we have a whole lot of things planned. It keeps me working. It keeps me busy. I want to say a big thank you to my family because they have given me the time to do a lot. In most cases, I am just here studying, putting information together. To make a 13 minutes video, it sometimes take you a day or two. 13 minutes because to put the content together, to ensure that you have the right thing to meet the right audience, to go through both syllabus to ensure that the content is fitting for both HSB and bio, it takes a lot. So for those persons who are here this evening and you are doing human and social biology, you would have seen for the video that we sent out yesterday, the pacemaker is in that video. The bio students read it's not on the bio syllabus, but nothing is wrong if you know about the pacemaker. But the students for human and social biology, you are supposed to know about the pacemaker and, of course, the artificial pacemaker. The pacemaker is that group of cells that are at the top of the right atrium, and they are the cells that cause the heart to be beating ever since you were conceived the early part of conception there. Uh, so a lot we have done and a lot we will continue to do. We have your support and we're very, very grateful for that. Last week we asked for 3 persons to subscribe, and I must report to you we had more than 3 subscribers last week. Sunday, might I say, I think I have some 58 subscribers for the week. But this week, like all other weeks, we're going to be asking for more subscribers. So for this week, your quota for the show before the show ends, we want to have 60 subscribers for the show. So it means that you're going to be calling somebody, you're going to be ringing up somebody, you're going to be reminding somebody about the show. Of course, you would have heard from the Guyanese last Friday. She is pretty much in she has fallen in love with the show. She thinks that the show is pretty much in line with the syllabus and what she is doing. So what will we do this week? A lot. I'm going to be going through graph and I'm going to be listening to you. Remember, the show is a 3-part show. So half an hour, then an hour. And then we could break down the 2 half-hour a little shorter and go longer with the content. So the show this week, and I'm coming from the syllabus. I am reading from my notes I got from the syllabus. We're supposed to identify the material to be transported by plants and animals, but we are not going to be looking at plants for this show. We're going to be doing plants by itself. We're supposed to be looking at some of the material transported would have been things like oxygen, carbon dioxide, hormones, nutrient, glucose, amino acid. Those we took directly from both syllabus. Then we're supposed to look at the blood vessels that are supplying the following organs. Blood vessels that are supplying the lungs, the kidney, the liver, the brain, and the intestine. Might I say, the syllabus has written below this only, the word only. So we are only supposed to look at these 5 organs. So we're going to be looking at these 5 organs and the blood vessels that are supplying the organs. Now, we looked at the video we put out this morning with double circulation. We did look at, we compared the blood vessels as to the interrelation among the blood vessels, not as to the structural and the functional differences that we're going to be covering in this lesson. So in that lesson, we did show you how these 5 blood vessels work together. And I'm going to be touching that, and then I'll be coming over to you to have a better understanding of what is happening with you at school. How was school last week? Was it better? Is the internet service getting better? What is your preferred platform? Is the videos, are the videos helping? That type of thing we want to know. So that we're going to be doing. Hi, Claudia and Car. I'll be talking to you just in a bit. So we spoke about the 5 blood vessels. Oh, just before we get to the blood vessels, we're also supposed to relate the structure of the components of the blood to their function. We're supposed to be looking at plasma, We're going to be looking at serum for HSB. Everything here is for bio and HSB, but where it stands out for HSB and not for bio, you'll hear me say for HSB. So we're going to be looking at plasma, we're going to be looking at serum, we're going to be looking at platelets. Diagram for red and white blood cell is required. And that is exactly from the syllabus. That is what the syllabus is saying. So I took that from the syllabus to ensure that we have the right thing. So pretty much that's the lineup for the show this week. It might sound as if it's a little bit of stuff to cover, but from what we have known with the explanation and as other persons join and the misinterpretations come up, we have to treat with them. But before we get into the show, while we wait on others to join, I want to look at a graph. Now, graph is one of those statistical skills that we need to acquire for any exams. Anything that has to do with school to analyze data, it's very important that we understand graphs. And the graph I want you to look at this evening is the graph that is called the histogram. All right, I'm going to ask you to just type in the chat there for me. Just describe the histogram, what it looks like. Or should I ask, how does the bar graph differ from a histogram? Just type in the chat there for me. Let me know that you're hearing me loud and clear so we can proceed with the show. How does a bar graph differ from a histogram? Don't fall asleep on me now. It's too early. All right, Claudia and Carr, can you say, would you like to say yes or no? It's fine. Would you like to answer that, Claudia and Carr? Shazina, would you like to answer that? Good afternoon, sir. Shazina, are you Jamaican? Juliana Walker, how you doing? Juliana, your teacher is saying that you are supposed to call the others to come online. I got that message from your teacher. Call the other students of her class to come online. Sisters, Goulburn sisters, how you doing? Nobody is saying anything. Nitisha, are you hearing me? Can somebody respond? Yes, no, maybe so. Let's pop the show. I have some past paper questions that I really want to push off for the revision part of last week class, which comes up in a... Whoa, we're there now. No, we're not there. Sorry. We are like 12 minutes away. All right. So Juliana Walker, yes, sir, we are hearing. Very good. So Juliana, your teacher is asking that you ask the others to come online to ensure that you have the content you should have for your class. All right. So being that there is no answer for that question, I'm just going to go right ahead. Histogram is used. The histogram, they are used when both variables are numerical. The histogram is used when both variables are numerical and related to similar things. Are you hearing? Yes, no? Are you with me? Are you following with that? Is that true? The histograms are used when both variables are numerical and related to similar data. Yes, no? Do you agree with me? Oh my, they're asleep this evening. What's happening? All right, I'll wait until you're all set. I go with that question. Nitisha, this is a question for you. How was school last week? Was it better than the week before? Juliana Walker, how is the software that you're using for school? Is it getting better? Are you logging onto the system easily now? Okay, so I will just go to the viewers since those persons who are locked and loaded, they are not talking to me. I don't know what I have done. I am going to, Juliana, we have a Wi-Fi problem still, sir. Internet is slow. Oh, I see the internet is slow. So as a result, there's a log. Okay, internet is slow. Internet is slow. I see. Very good. Understand. All right, since the internet is slow, I am not going to the graph just now because I really don't want to tell you everything. I want to pull some information from you and help to modify that which you already have. Now, what I'm going to be doing now, I'm going to be looking at what we did last week, Sunday. So I'm going to be doing a quick recap of what we did last week, Sunday. Then I'm going to go to 3 years worth of past paper questions, and I'm going to be asking you some questions that are directly related to what we did last week. So the first thing I'm going to be asking you, we spoke about surface area to volume ratio. And when we did last week, I think it's the first thing in the circulation. It's the first thing for us to cover for circulation. When we did that, we said that small organisms like the amoeba, which are pretty much single cell, they are able to live life just with simple diffusion. They don't require a sophisticated transport system. However, mammals like you and I, larger organisms, we require a sophisticated circulatory system. And one of the reasons we said we did a little mathematics that we proved that we needed that. I gave you a number of scenarios. And what we remember from maths is that when we did that calculation with the cubes is that the smaller cube had a surface area to volume ratio of 6:1, while the larger cube had a surface area to volume ratio of 2:1. And then we said the reason for human or for larger organism needing to have a circulatory system, it is because of the limitation of their surface area to volume ratio, right? And we made it very simple by saying the inside is too far from the outside for diffusion to take place. It's not the same for the single cell organism. Note, I am not saying that diffusion does not occur in our body. We continued, and I think we looked at some blood vessels. We looked at some components of the blood, and we skipped and scanned over a number of stuff, right? How much you learned, I really don't know, but I'm going to know now because I'm going to be asking you some past paper questions. So here we go, right into the past paper. You said that the internet is somewhat lagging, so I will read more than one question and wait for the responses. So here we go. This is how we're going to be kicking off the evening. All right, so here we go. I'll tell you the past paper in a bit. My system is a little slow, just the same. All right, so here we go. The right ventricle collects bloods from the A, aorta, B, vena cava, C, right atrium, D, pulmonary artery. So the question is, the right ventricle collects blood from the A, aorta, B, vena cava, C, right atrium, D, pulmonary artery. What's your answer for that? Let me hope that we're not logging. So the question is, the right ventricle collects blood from the A. It's a multiple choice question. All you need to write is A, B, or whatever, or if you know which one. So I want to know, where does the right ventricle gets the blood from? The blood entering the right ventricle, where is it coming from? All right, like oh, I am sure that if I'm getting to C, then I must pass B. All right, serious log with the internet. All right, while I wait on the responses, let me give you another question. And this is one that we just did. It says here, question number 19. It's a past paper question somebody sent to me. An amoeba obtains all the oxygen it needs by diffusion via its cell membrane, while a human needs to have a special respiratory surface for this purpose. The best reason for this difference is that, okay, so persons are answering now. So the right ventricle, it is getting the blood from the, somebody is saying right atrium, another person is saying vena cava. All right, is there any other question, any other answer? Any other answer? I'm waiting on some more answers. Let me tell you the answers that we have, the options you can choose from. You could say it's coming from the aorta, or it's coming from the vena cava, or it's coming from the right atrium, or it's coming from the pulmonary artery. The question is, the right ventricle collects blood from the, and this is a past paper question. It's a multiple choice paper that I'm looking at. So see how best you can answer it if you are exam ready. All right, Nitisha is saying the right atrium. This is a 2014 past paper. All right, so 2014 past paper sent to me. All right, I'm going to answer this very quickly. Your answer is always going to be the right atrium. Right atrium. Right, remember the vena cava. After the vena cava, you're going to have the right atrium, then you're going to have the right ventricle. Please ensure that you know your diagram of the heart inside out. Let's get to the other question. An amoeba obtains all the oxygen it needs by diffusion via its cell membrane. All right, good, Shakila. All right, via its cell membrane. While a human needs to have a special respiratory surface for its purpose. For this purpose, the best reason for this difference is that A, listen, this is your first response, or the first choice you have. The amoeba does not require much oxygen. That is why the amoeba does not need a sophisticated respiratory system. That's for A. B, oxygen cannot pass through the skin of a human. C, a human requires a larger volume of oxygen. And D, a human surface area to volume ratio is too small for diffusion to be effective. What is your answer? You could write A, B, C, or D, or you could write the entire response if you wish. All right, so give me the answer to that, and then we are going to be moving on to another paper. All right, so that was question number 18 and 19 from the 2014 paper. Question number 18 and 19, that's the question we answered just now from the 2014 paper. Let me have a response. Should I read the question again? Do you want to read the question again? An amoeba obtains all the oxygen it needs by diffusion via its cell membrane, while human needs to have a special respiratory surface for this purpose. The best reason for this difference is that, all right, Shakila is saying D, and D is a human surface area to volume ratio is too small for diffusion to be effective. All right, Shakila said yes, I'm locked into D. Is there any other response we want to share? Walker is saying D as well. Is there any other response we want to share? Walker is saying D. Shakila is saying D. Is that really the right answer? Why is everybody saying the same thing? Is it that great minds think alike? No other answer? All right, so we're going to be going with D for the answer. Of course, that is the answer. We have said it over and over. It's something I want you to have all locked and concretized. Let's look at this one. We touched this one last week. This paper is the, let me tell you which paper I'm looking at. I'll tell you in a bit. I can't see it now. I'm not too sure. Somebody sent it to me. All right. The following are description of blood vessels. 1, thin wall, large lumen, takes blood away from organs and tissues. So that's the first one. The other one, thin wall, vessels adapted for diffusion close to cells. 3, thick walls, small lumen, takes blood to organs and tissue. So now you are going to be selecting which of the following correctly identifies blood vessels described above. So one, let me read again. One, for A, the responses are one would have been artery, two would have been vein, three would have been capillary. B, one would have been vein, two would have been capillary, and three would have been artery. Then C would have been capillary, veins, artery. D, artery, capillary, veins. Now, let us go with this one. I'll do it again. The first thing you need to do in answering this question, you need to identify which blood vessel they are talking about. So let me go again. So one would have been the walls, thin wall, large lumen, takes blood away from from organs and tissue. Two would have been thin-walled vessels adapted for diffusion close to cell. The other one is going to be thick wall, small lumen, takes blood to organs and tissue. What is your answer? A, artery, vein, capillary. B, vein, capillary, artery. C, capillary, vein, artery. D, artery, capillary, vein. What are you choosing for your answer? All right. While you work that one out, let's look at this one. The function of a valve in the vein. A, lower the pressure of blood. B, increase the pressure of blood. C, prevent backflow. And D, push the blood forward. What's your answer for that? What's your answer for that? All right, so Nitisha is saying A and D. What is A for? I'm not too sure if this is the question you're answering. So is D for the answer we asked before, and A for this question? Let us know which of it. What is it that you're answering? Wow, the internet is really crappy today. Nitisha? All right, Shakila Lewis is saying C first. So if Shakila is saying C, she's saying that capillary vein artery. All right. Juliana is saying valve prevents the backflow of blood. Yes, that is true. Sanada Times is saying, sir, your respect. Blessing. Natisha Francis, the valve question ID. The valve. Okay, so you are saying the valve is D. Let me read what D says again. Let me see if you'll keep your answer. So D is saying that the valves help to push the blood forward. Is that what you wanted to say? Oh, it prevents a backflow of blood. Yes, that's what the valves do. All right, so I see that nobody is really trying out for 23. Question 23, this could be a 2015 paper. Yes, it's a 2015 specimen paper. So 23, the answer is going to be B, vein, capillary, artery. And we're going to be looking at that today. So I'm going to be looking at the 2015 exam paper now. So we looked at 2014 paper, we looked at 2015 specimen paper, and now we're looking at 2015 exam paper. Now, question 21 refers to the following diagram of a blood vessel, and it shows three nice blood vessels. I can't even tell you what they look like. Probably I should up over this one and move on to something else. Let me up over to this one. And when we talk about the blood vessels, I will tell you more about it. So this one is saying, which of the following components of blood could surround, which of the following components of blood could surround and engulf pathogen? So what component of the blood could surround and engulf a pathogen? Anybody can answer that? All right, so let me tell you what we have. We have some cells, but I'm going to be identifying the cells for you. The cells have no name on the exam paper, but the first cell, A, is going to be the lymphocyte. The second one, B, is going to be the phagocyte. C is going to be the red blood cell, and D is going to be the platelet. But might I say, on the exam paper, the name of the blood vessel is, the name of the blood cell is not there, just the pictures of the blood cell. So, sir, repeat. Okay, I'm asking which of these let me use the same word the exam paper has on it. It says which of a following component of blood could surround and engulf pathogen. All right. So I was saying to you what's on the paper. On the paper, the name of a component is not there. It's just the pictures of a component. And the pictures of a component that they have there, it's actually 4 blood cells. One is going to be the lymphocyte. The second one is going to be the phagocyte. And the third is going to be the red blood cell. And the fourth is going to be the platelet. So what we want to know is which of these will engulf a pathogen. Will it be the red blood cell for A? Sorry, will it be the red blood cell for D? Will it be the lymphocyte for A? Will it be the phagocyte for D? For B? Leukocytes are red blood cell, you know. Amyloid, leukocytes are red blood cell. A is actually the lymphocyte. That's what you wanted to say, Nitisha. Phagocyte, that is going to be B. Is that what you wanted to say? So we have 3 responses. One is saying leukocyte, and what exactly you want? The leukocyte? Let me go again with what we have. We have lymphocyte, we have phagocyte, we have the erectocyte, which are the red blood cell, and we have thrombocyte, which are the platelets. What is your response? What exactly do you want to say? All right, the answer is going to be phagocyte. All right, and we're going to be covering that in this lesson. Just one more question from this paper. No, it's not platelets. Remember that platelets are really for blood clotting. So it's not going to be platelets. It's always going to be your phagocyte. Question 23. Which of the following are involved in the formation of blood clots? And we have platelets, antibodies, phagocyte, lymphocyte. Which of those would be involved in blood clotting? Platelets, antibodies, phagocyte, lymphocyte. Which would you choose? Yes, it's a platelet. Surprisingly, this exam paper has about 5 questions on circulation. Usually we really don't have that much questions on the paper for one topic. Now, on this paper, let me see which paper this is now. On the 2016 paper, surprisingly, there is a diagram of the heart, one which I did not cover. Yes, it's a platelet. One which I did not cover. It's very interesting. I would love for you to look at the diagram of this heart. I don't know, I'm probably going to take a picture and show it to you or something. The thing about this heart is that it has no flow diagram. It has no labeled part. It is just the heart, and it's more like the external view of the heart with a piece of it cut away. So you would have to be able to identify like the aorta in order to identify the parts of the heart. I'm going to be upping away from that. Sir, that's paper 1. Sir, that's paper I failed 2016. Never mind, Lawrence, you're not going to fail any more paper. All right, and we have this all answered, so probably you could just follow us. I'm not too sure if we have it online as yet, but if not, we're going to be answering some of these for the students and have it online. All right. It was a nice paper, I think, though. Wonderful paper. All right, so we're going to move away from that. I don't know how well you fared with those questions. We might go through them again in the program. I realize that the internet service is like really, really, really poor. So what we want to look at first, we want to look at, you saw a question there about components of the blood. Now, components of the blood, when we talk about components of the blood, we are talking about what really makes up the blood. All right. Components of a school would be the teachers and the principal, the student, the desk and the chair. All those things that you are going to be, that's going to, oh my, these boys. All those things that are going to ensure that the set is complete. All right. So the components of the blood are going to be, you want to start telling me? I want to listen to you because you haven't been talking. You made mention of marathon. When would that be? When are you doing the exam, Amoy? January or June? So flow is giving. That's what I realized. We're going very, very slow. And that's sort of fuel from me, when you're burning, I'm burning as well. All right. Amoy, when are you doing the exam? June. All right. So if it's June, my students are doing the exam June as well. Are you in Kingston, Amoy? Are you in Kingston? If you are in Kingston, no, where are you, Amoy? All right, it's so nice. No, we don't even have to be in Kingston. We can be anywhere in the world. I can tell you how that can be done. Oh, you're in Spanish Town. That's just over there. All right, so it's just a stone throw away. So with Zoom and all of that, we have online classes. That's how we do a lot of the courses online now. I can talk more about that as we get closer. Might I say that we are going to be having a Wednesday class, a Wednesday live. In the Wednesday live, we are going to be covering ecology. All right, so we're going to be having 3 lives now because we're trying as much as possible to complete the syllabus. All right, so we're looking at the circulatory system, and let me just start all over and just get this thing out of the way very quickly. All right, circulatory system consists of, what are the 3 major components, or the 3 components of the circulatory system? Write them in very quickly for me. Components of the circulatory system. 3 of them. Tell me them very quickly. 1, 2, 3. 1, 2, 3. What are they? Blood, heart, that's 2. Any other? White blood cell, red platelets. No, those are components of the blood. Juliana Walker, those are components of the blood. Barnett, no, the lungs is going to be a part of the respiratory system, not a part of the circulatory system. Adi, yes, the other one is going to be the blood vessel. All right, very quickly, as we keep it going, I like what's happening now. What's the function of a heart? What's the function of a heart? Go with it very quickly. I like what I'm seeing. I like when I see the screen keep going. It means that it's time to start working. All right, the heart. Very good, Shakila. No, what is the function of a heart? Very quickly. What's the function of a heart? All right, blood vessel. It pumps blood around the body. Wonderful. Any other answer? I hope nobody will write that it helps you to fall in love, because that is not probably one of the better answers for us to even choose. So the heart pumps blood around the body. Yes, that's what it does, pump blood around the body. Carry oxygenated blood and other important, oh my works. All right. Juliana Walker, just hold it one little bit. Hold it one little bit. I do appreciate the fact that you're giving some answers. I'm not too sure if we're having a log or what. You're giving answers to some stuff, but it's not the things that we're asking. You have to take it a little slower. So let us go again. What we want to find out now is, what is the function of the heart? Sir, I'm in Trinidad, but I am very interested in the marathon and the internet only loading from time to time. All right, Floyd, you're in Trinidad. Oh, my work. So we're going to want it for our cultural exchange at the end of the show. That's fine. All right, so Shaquilla Lewis, it pumps blood all over the body. Wonderful. All right, so that is what the heart does. It pumps blood. Now, let us get to the blood vessels. What are the blood vessels? What they do? Yes, the heart is a muscular pump. What are the blood vessels? What they do? What's the function of the blood vessels? All right, we're going to be talking biology like it's our language, you know. What's the function of the blood vessels? Just name a blood vessel or just tell me the blood vessels, whatever you want to say. All right, I want to pick on somebody. I want to go to Juliana Walker. Let me try. What's the function of the blood vessel? Go with me, wrong or right. We can work with it. Function of a blood vessel. What do blood vessels do? Juliana Walker, what do blood vessels do? Oh, is that another Lyme thing? The internet not working so well. Function of the blood vessels. Oh, that's why I like to ask questions. All right. All right, so the function of a blood vessel is really to carry the blood. Now, bear in mind that blood is a mixture. All right? Bear in mind, function of a blood vessel, the blood go through. The function of a blood vessel is actually to transport the blood, to carry the blood from one place to another. Now, I started out by saying, I'm going to be going through the lesson now. I started out by saying that there are 5 types of blood vessels. We have the artery, the veins, and the capillary. Now, those are the major blood vessels: arteries, veins, and capillaries. All right? Very good. Oh, wow, a whole lot of things has been said. All right, just slow down for me. I'll get back to you in a bit. A whole lot has been said, but just follow me now. So we have the arteries, we have the capillaries, and we have the veins. But the blood vessels, they don't work in isolation. It is not like there's a blood vessel over here and, hey, my mother said, I'm not talk to you over here. So no, at some point, they must work together in order to get the job done. Now, so how they get to do this is by pretty much making themselves into smaller vessels. So what you'll find happening, if my hand were supposed to be like the artery, so this is like the artery, this hand here, and the artery here is carrying blood, of course, towards organ. Now, the artery would have reduced itself into smaller blood vessels like my fingers. These would have been smaller blood vessels. All right. Now, these smaller blood vessels we would have called them arterioles. Right. So we have the artery, we have the arterioles. Then this hand now is the vein. So this is the vein, and then it too will break up into some smaller blood vessels. We would call those venule. Right. So look at what is happening now. Most of the, I want to say most, pardon me with the pulmonary artery and the pulmonary vein. So the artery in most cases, except the pulmonary artery and the pulmonary vein, the artery in most cases will be carrying oxygenated blood. That is blood rich in oxygen. So look what happens. It comes to a cell where it's going to unload that oxygen, but the blood must continue around the body. Now, the artery is not the blood vessel that is taking the blood back to the heart, right? That's not what the artery does. The arteries, they are actually taking blood away from the heart. So if the artery is taking blood away from the heart, then how will the blood get back to the heart if at no point the artery and the vein will meet? So let's talk about the meeting place for the artery and the vein. They have a little meeting place that they call capillaries. Capillaries are actually smaller blood vessels. And I did that in the video I published today. Capillaries are smaller blood vessels. So let's go again and see how we are going to join up. I'm going to find something to join. I really don't. All right. If I were supposed to have some smaller strips, I'm going to try to use these strips as being smaller. I just want to give you the concept, and I'm going to be using these. All right. So I could probably just reduce these in two. So look what happens now. So these white papers, they are going to be the capillary. All right. These are my capillary. So let us go with that analogy again. I'm trying to show you that the blood vessels are not in isolation of each other. It is not like one of the blood vessels over here and say, hey, I don't like you over there, you know, because guess what? You don't carry oxygenated blood, so I'm not going to deal with you. No, the blood vessels don't work like that. What the blood vessels do, the artery will be reduced into smaller blood vessels called arteriole. The veins will, this is the vein, it also will be reduced into smaller blood vessels called venules, and my fingers are the venules. And then these venules are going to reduce into some smaller blood vessels, my paper here, called capillary. Now, these arteriole, they too are going to be, the arterioles, these are going to be reduced into smaller blood vessels, and those blood vessels are going to be called capillaries. And they meet in what we refer to as a capillary bed, and I will deal with that sometime soon. And then they are one cell thick, and these are probably the only blood vessels that carry both oxygen and oxygenated and both deoxygenated blood. And I'll explain that to you further. So this is where they meet up now. So you find out that the circulation is completed because here the artery was carrying the blood. Hey, I'm carrying some blood around the heart, around the body. But guess what? When it reaches under the foot bottom, there's no blood vessel to carry it back up to the heart. What is going to happen? You're going to die. Yeah, you're going to die. But guess what? The body is not like that. You're not going to die. It's going to just connect up with the capillaries here, send over the blood via the capillary to the venules, and the venules are going to send it to the veins, and then the veins are going to put it into some larger vessels until it gets up to that vena cava and it gets back to the heart. Do we understand that? Do we have a question for that? No, we are questioning the content. Do we have a question for that? All right. So we understand now the relationship that exists with the artery, the arteriole, the capillaries, the venule, and the vein. Are you with me? You can just say yes. I'm going to be asking you a lot of questions as I go through my notes. So we are looking at the blood vessel, and I want to take it there. Now, as I ease the tension on your brain, no, I'm not going to ease it. I'm going to put on some more fire. I think you deserve the fire. I think you deserve the fire. So let us go again. So we're talking about the blood vessels, and you are supposed to be able to identify the blood vessels. So you're not going to talk about description and function. You need to know what they look like. You need to know what they do. You need to know their limitations. Now, the first thing I like to talk about, I'm going to be doing something. I am always doing something that some persons don't want me to see. I have my 500 pack of paper, so I go drawing again. All right. So I have my 500 here. The first thing we want to talk about the artery. We're going to spend a little time on the artery, and I'm going to be doing some drawing. All right. So I'm going to draw a big one. All right, good. So if I were supposed to draw the artery, the first thing I would tell you is that this little space here that the blood passes through, it is small. It is small. Most persons don't like anything small, but this would be small. For the artery, it is small. It is called the lumen. All right, that little hole, that little space in the blood vessel, it is called a lumen. For the artery, it is small. Are you with me? That's the first thing you want to remember. The artery, that space in the artery, that hole, that lumen, that place that the blood travels through, it is smaller than it is for the vein. Are you with me? Good. Now, the other thing being that we are comparing them, the vein would have a larger lumen. I'm comparing them now before I get into the specifics of each. So the vein would have a larger lumen. So if you were supposed to see them on a paper, in most cases they would have been drawn like this, and you would have seen probably the capillary being drawn something like this, with some, it showed some cells on it and something like that. You might see it looking something like that. So in most cases, you might see the capillary like a tube thing with something like that. If it's even a piece of the capillary, they'll draw it looking like a tube thing like that. All right. So the first thing you need to be able to do at a glance when you see these pictures, because CXC is serious on it now, they're just giving you pictures without anything and you have to identify it. So when you see these three blood vessels together, I had about 4 of these questions on the paper we looked at a while ago. When you see these at a glance, based on the thickness of the wall, based on the size of the lumen, based on the size of the blood vessel, you should be able to identify the blood vessel on your exam paper. Now, one of the things that we want to talk about, and I cleared this up in the video I did last week, the presentation. Let me go through the lesson very quickly. All right. So never ever say that arteries carry oxygenated blood, unless you are going to clearly state that there's an exception, as it were, for which of the artery does not carry oxygenated blood. Can you type it in the chat for me? I want to have a conversation. Which of the artery does not carry oxygenated blood? Very quickly. Which of the artery does not carry oxygenated blood? All right. I am not going to tell you. I'm waiting on you. I'm going to continue with the lesson. Now, remember that arteries transport blood away from the heart. That is something that is always true. The arteries always carrying blood away from the heart, right? While veins are always carrying blood towards the heart. Now, another thing that is true about the artery is that the artery has blood under high pressure. The artery, it has blood under high pressure. It is like a fire hose. You know that fire hose from the fire truck with a whole lot of pressure? Juliana Walker, you're correct. All right, so the pulmonary artery is the only artery that does not carry oxygenated blood. Wonderful, I like that. All right, so the artery, it is like a fire hose from the fire truck with blood under very high pressure. I hope you have that. The other thing that you want to know, if the blood is under high pressure, then the blood is moving very, very fast in the blood vessel. Very, very fast. Now, another thing that you want to know, we made mention of it, that in most cases, the arteries are carrying oxygenated blood with the exception of the pulmonary artery. That is how we started out. Now, it's also important to note that the arteries, they have no valve. They have no valve because they are carrying the blood under very high pressure, and the chances of the blood flowing backward is sort of remote. It's remote. Of course, the blood is losing pressure as it makes its way around the body, but the artery does not need to have a valve as would the vein. So if you ever see a blood vessel and there is a valve or something drawing looking like a valve, that cannot be your artery. That must be your vein, because it's the vein that has the valve. I want to make some exception here. In some cases, listen to this very carefully. In some cases, that semilunar valve that is between the right atrium and the pulmonary artery, in some cases, it is said that the artery has a valve. If it is ever said that the artery has a valve, it is that valve that they are talking about. However, you and I know that that valve is inside of the heart, but I have seen literature where they are saying that the artery, the pulmonary artery, has a valve, and if the pulmonary artery has a valve, it's going to be the semilunar valve. All right. So arteries typically they don't have a valve. And remember, in all cases, your valve is preventing the backflow of blood. All right? Are you with me? Is there anything you want to ask me before I move on? Type it in the chat. Don't wait on me. Just type it in the chat. I'll stop and listen to you. All right. It's very important to note as well that the walls are composed of 3 layers. So you saw me drawing here 3 layers. The walls are composed of 3 layers. With the outer part, I don't want to tell you what they are composed of. I want you to look at it because you can't get a picture from what I'm saying. While we're talking about it and we're going to be looking at the difference, and I am going to put a little bit to it that is not in your text, I want you to ensure that you have a look at the diagram. You are able to draw them. You are able to draw them. You are able to identify them, and you are able to tell about the function. And this is for both HSB and biology student. Let us look at the capillaries. Now, the first thing I can remember about a capillary is that it is single cell, 1 cell thick. 1 cell thick, single cell. When we think about the capillary, they are always, the first thing must come to your mind is that they are single cell, 1 cell thick. Now, another thing you need to know about them is that the blood in the capillary is usually traveling very slow. The blood in the capillary is usually traveling very slow. All right. The blood pressure in the capillary, do you think it is high or low? Tell me in the chat. The blood pressure in the capillary, is it high or low? Blood pressure in the capillary, is it high or low? Tell me in the chat. Now, another thing I need to tell you about the capillary as you answer that question or prepare to answer that question is that the blood, Juliana Walker, it is low. So the blood pressure in the capillary, Juliana is saying that it is low. Roberts is saying that it is low. Is there anybody else who want to say it is high or low or in between? John C is saying that it is low. And in most cases, all these answers are correct. I like that. It's low. Barnett is saying that it is low as well. And Amoy Lawrence is saying that it is low. So, of course, the blood pressure in the capillary, it is low. Now, while the blood pressure in the capillary is low, it is also important to note that the capillary does not have a valve. This is going to be tricky because when we talk about the blood pressure in the vein, somebody's going to ask, what's happening here with the vein versus the capillary? Low, slow, and one has vein. But you have to remember that the capillary, they are 1 cell. So they are very, very small. They really don't need a valve. No, they don't need a valve. They really don't need a valve. All right. The other thing we need to know about the capillary is that they might be the blood vessel that is able to carry deoxygenated blood as they travel through the body. And of course, at times they are carrying oxygenated blood, because if you remember the analogy here or the example here, the arterioles are going to be broken down into capillary and the venules are going to be broken down into capillary. So at some point they will have to pass the 2 different state of the blood, that is oxygenated and deoxygenated blood. Now we want to look, and you need to know the diagrams. Please ensure you know the diagrams. So I'm going to come with some diagrams next week. I'm going to hold them up on which diagram is this, which diagram is this. And I wasn't satisfied how we did the quiz this evening. I wasn't satisfied. It makes me feel as if I did no teaching last week. Guys, you want to ensure that you do my tests. I really don't like students failing my tests. I am that type of guy who go overtime to ensure that you pass. So if I do something, watch the video again, so that when I come, I'm going to be giving you a test from that video, and you really don't want to fail or make me feel bad. Now, we want to look at the veins now. Now, the veins are transporting blood towards the organ. Is that so? Yes or no? Answer. Who wants to go with me? Veins are transporting blood towards the organ. Who wants to accept that? Accept. Say yes or no. Yes or no is fine. Veins are transporting blood towards organ. If you think it's true, say yes. If it's not true, say no. All right. Reflex is saying yes. Roberts is saying no. Juliana is saying yes, that is correct. Sandra Johnson is saying yes. Reflex is saying, you know what? I really don't know. I really don't know. So the question, what was the question? We were saying that the veins, they are carrying blood towards organs. And Amoy Lawrence is saying yes. All right. The truth is, veins are really moving blood away from the organ because it's usually deoxygenated blood, with probably the exception of the pulmonary vein. Now, the blood flow in the vein, it's usually low, and the blood flow is usually slow, and the veins, they are carrying deoxygenated blood. It's Rafik. I'm very sorry. And the veins are carrying deoxygenated blood. All right? I didn't say this about the artery. I should have said it. I said it in the video last week, I think. The arteries, they lay very deep into the skin. And they lay deep into the skin, or they lie deep into the skin, because they have the blood under high pressure. And if you were supposed to get a little scratch like that and the artery were supposed to become ruptured, then you understand that you'll be losing a lot of blood. So for that reason, they are deep into the skin. The book said towards, go again. I asked you about the vein. The book is saying that the vein, all right, we can treat with that. Just I'll look at that. All right, so the veins, they lie close to the skin. They lie very close to the skin. Can you understand? They are not under high pressure, and if you're supposed to get a little cut, then the damage would not be that bad. Now, the valves, the veins are the blood vessels with valves. The veins, they have valves, and I'm going to say it for 1,000,000 times. The purpose of the valve, wherever you see the valve in the body, is supposed to prevent the backflow of blood. All right, Barrett, what are you saying no to? And Lawrence, what were you saying the book said? All right, because sometimes books do say a lot of things, but we want to bring clarity to it here. Don't be afraid to talk. Don't be afraid to talk. This is a place where all views can contend. All right, so the takeaway, what is going to be the takeaway? I'm going to be asking everybody something, because if you're here this evening, it means that you have something to share. You want to learn the bio. So I'm going to start from the bottom. Bennett, tell me one thing about a named blood vessel. So name the blood vessel and tell me one thing about it. Lawrence, name a blood vessel and tell me something about it. Rafik, name a blood vessel and tell me something about it. Johnson, everyone, choose that blood vessel that you prefer and tell me one thing about it. One thing about the blood vessel that you prefer. Sir, when someone gets a cut and blood is spraying, is the artery? That's a good question. But guess what? That would be very difficult for me to answer because I have not seen the person with the cut. It is not to say that if you get a cut and it's the vein that is cut, the blood won't run out, that the blood will stay in. But in most cases, when you get a cut, like if somebody get a cut like at the neck, and it depends on where that blood vessel is, all right, and how major that blood vessel is, the blood is going to spew. But in all cases where you have a cut on the artery and it's a big cut, it's going to shh. Because remember that the heart is pumping this blood. So if the heart is pumping this blood, it has the force to push the blood out with great force, and that is what causes it to spew. So I'd ask everybody to tell me about a blood vessel, their preferred blood vessel, and of course, what they know about that blood vessel. Very quickly, I'm going to go on back to the components of the blood. Remember, we are going to be completing the circulatory system next Sunday. So we have a lot to cover this evening. We are traveling pretty nicely though. All right, so we are looking at the blood vessels. We just went through the blood vessels, and to recap while you put your stuff together, we spoke about 5 types of blood vessel. We said that there are 3 major blood vessels. We spoke about the artery, which has blood under high pressure, has a very small lumen, and the blood is moving very, very fast. I also encourage you to look at the diagrams and make sure from your textbook you are able to draw the diagram. Amoy Lawrence out of Trinidad vein transport blood back towards the heart. And we can think about the vena cava, which is the biggest vein transporting blood towards the heart. And we could think about the pulmonary vein too, which is also transporting blood towards the heart. You're doing well, Amai. I'm very proud of you. The capillary is 1 cell thick. I like that stamp. That's a very easy one. Always remember that you want to be able to be able to identify the structure of these blood vessels. Though we can have worded questions, we want to ensure that we can identify the structure. Robert C. saying veins carry blood under low pressure. Wonderful. And Walker is saying the artery has a valve, and the vein and capillary. Oh my. Walker, let us go through that again. I'm going to be asking Amoy Lawrence to correct Walker for me. Look at what Walker said and see if you can correct it so that we can be on the same playing field. We don't want anybody to leave here with a misconception. All right, so we want to ensure that in this learning community, we share the content. We want to ensure that all views can contain, and we want to ensure that persons can speak with each other, not only Mr. Wilson. So Juliana Walker, I want you to look at what you wrote. You're saying the artery has a valve and the vein and capillary does not have a valve. Look at that and see if you want to revisit that answer. All right, so Stamp seek to correct it. She's saying that the artery is the largest vein. The aorta is the largest vein that carries blood away from the heart. I was at that stage one time. Let me tell you what is happening. We all grew up, you see, learning about blood vessel. And there was one blood vessel when I was growing up. I don't know where the other 4 come from. When I was growing up, the only blood vessel that there was the vein. And then as I grew older, and I started doing science, I realized that there were other blood vessels. So that large blood vessel that you spoke about, the aorta is an artery and not a vein. The aorta, Stamp, let me get back to that. The aorta is an artery and not a vein. The vena cava would have been a vein. All right, arteries carry blood away from the heart. All right, good going there. Lawrence, the artery has no valves. Very good, because blood is under high pressure. That is very good. So we want to correct, I think it was Lawrence. I'm not too sure. I think it was Lawrence. Remember that it is actually the vein that has the valve. However, the artery and the capillary, they would not have any valve. All right? They would not have any valve. Let me look at what is happening here. Veins carry blood back to the heart. Wonderful. Stamp. The lumen of a vein is larger than the lumen of an artery. Wonderful. That is so correct, Stamp. You have it all, we'd say in Jamaica, you have it locked. Now, guys, I don't want you to leave a class today and not study. When you get back here next week and any question I pose on this, you must be able to answer it. Don't just come here and just waste your nice Sunday evening, chicken evening. You want to ensure that you're able to answer the questions next week and you are getting closer to that one. I want to now move on to that which is syllabus that we should look at. Did I rip up my paper? No, I did not. All right, so the syllabus wants us to look at these. It said that we should identify the blood vessel that is supplying the lungs, the kidney, the liver, the brain, and the intestine. Now, if you ask me, let me see what's happening here. Juliana Walker, lumen, all right, correction, sir. The artery and capillary does not have a valve, and the vein. Thank you very much. That's wonderful. That's wonderful. Always take some time to correct yourself. All right, good. So there's just the mesenteric and hepatic portal. Those might give you a little problem, but the others, you would have known them long ago. And I'm going to show you that you know them long ago. Let us start here. The first two blood vessels that you need to say you know already, and don't go study, the first ones would have been those associated with the lungs. Those two blood vessels we talk about 5 trillion times. What are they? The blood vessels associated with the lungs, taking blood to the lungs and away from the lungs. What are they? Write them in the chat there for me. The blood vessels that are associated with the lungs, you should know them, man. Come on, we've said them several times. These two blood vessels, the anomalies associated with the lungs, what are they? The blood vessels that are associated with the lungs, tell me them very quickly. Quickly. What does that mean? Is this internet? The blood vessels that are associated with the lungs. We've done them several times today. They are probably the only two blood vessels we keep calling. Well, they are among the blood vessels we keep calling. All right. While you think about what those two blood vessels are, Juliana Walker, no, you have to get back to the book, Juliana Walker. Robertson, you will have to get back to the book, Robertson. But I like the fact that you have tried. Amoy Lawrence, you're burning. Come on, that's one. Go with the other. All right, who wants to help Amoy? Who wants to help Amoy? What we want to understand and what we want to know here, we want to know the blood vessel that takes blood to the artery, to the lungs and away from the lungs. Please be reminded you are going to go on over and watch these videos I have on circulation. They will help. So we have the pulmonary artery and the pulmonary vein. Now remember, your syllabus say that you are supposed to know that. I'm not teaching you buffer information. HSB and biology, you need to know the blood vessel that carries blood to the lungs and take it away from the lungs. So that was an easy one. So you see, when you are studying, you already know that, Juliana Walker, you already know this one because we keep talking about this. The pulmonary artery and the pulmonary vein, they are associated with the lungs. The other blood vessel that you already know is one that we call renal something. You hear persons going to the hospital because they have a renal defect. You spoke about renal when you haven't done the excretory system as yet. Some persons might have. All right. So we spoke about the renal artery and the renal vein. Once we're talking about renal, we are talking about the kidney. Once you're talking about renal, we are talking about the kidney. So we have the renal artery and the renal vein. Follow me. I want you to go closely. I don't want you to miss anything, because today, when you leave my class, you must be singing some of the things that I have been saying. So we are looking at some of the major blood vessels. It says we are supposed to know the blood vessels that are supplying the lungs, the kidney, the liver, the brain, and the intestine. And the one that is going to give you a little problem is the one for the intestine. But we are going to be getting over that. Because what you are going to be doing by this, everybody would have their little white paper. Because we spoke about white paper. And if you don't have any white paper, you need to have a little post-it. All right? There are some little things that you're just going to just jot them down. You know, I need to know this by the end of the week, and you put it up on the fridge, or you have it somewhere that you visit. Put it in the bathroom. My bathroom is a sacred place, so I write everything in the bathroom. All right, good. So let's go again. Let's get better at what we know. The blood vessel that is supplying the lungs and taking blood away from the lungs, what is it called? Put it in the chat for me. Everybody, or if somebody write it, you write it again. Let's go. We are going to do all of them. After we have completed this, we are going to move on over to the components of the blood, that 45, 55, that 60, that type of thing. 90, 10, that we're going to look at that. All right. And then we want to also look at the blood cells. All right. So there are about 600 more red blood cells than there are white blood cell. There's more phagocyte than there is lymphocyte. All that I need to detail to you and why you need to know it for the exam. So we have that bit to complete. All right. So I'm not too sure if you're hearing. I'm not too sure if you're shy. But if you're shy and if you're not hearing, let me do some correction here. I started out by talking about the lungs. Repeat. I'm going to repeat. We want to know the blood vessels that are taking blood to these organs and taking blood away from these organs. The organs are, I started out with the lungs because we've been working with the lungs. And if you are doing circulation now, it means that you would have just completed respiration, right? So the lungs, the blood vessel that is supplying the lungs, as Amoy said, it is going to be the pulmonary artery and the pulmonary vein. The pulmonary artery and the pulmonary vein. Then I went on to the kidney, because the kidney is also a popular one because persons have renal defect. So the kidney is going to be the renal artery and the renal vein. You really don't want to forget that. The renal artery and the renal vein, they are responsible for the kidney, taking blood to the kidney and away for the kidney. Of course, the artery is going to be taking blood towards the kidney and the vein away. Are you listening to me? Let me just tell you this now. So when you are doing that diagram for the, I think it's a diagram for the excretory system, where you have the kidney and you have the blood vessel and so on. Now, in that case, in order to identify the blood vessel, you must look for the flow direction of the arrow, because I don't know that you're going to be seeing the color of the blood on the paper. But if the blood is going towards the kidney, it is always going to be your renal artery. If the blood is going away and you're looking at the arrow, if the blood is going away, it's going to be your renal vein. But I'm going to be talking now about those in your neck. So we spoke about the lungs. We spoke about the kidney. I said the intestine is a tough one. I'm not going there yet. I'm going to those in your neck. And I hope I don't have any minor in the class now, because I am just going to just talk some stuff. I tend to do that. I teach biology, so I tend to talk a lot of stuff that is biology, and I tend to teach street biology as well. All right, I teach that for those persons who don't know me yet. So let me go there. There are some persons, you see, who want to, in agriculture, we tag the animals. I'm a trained agriculturalist. We tag them with the ear notching and all of that, ear tagging and so on. And there are some persons who want to tag human as well. So they do this vampire thing on the neck, clinch onto the neck and all of that. And then it leaves on the neck a big red spot. I really don't want to say all the details. All right. It is not safe. It is not safe. Do not allow anyone to brand you. You're not a cow. All right? So let us deal with this now. To the left side of the neck here, we have an artery called the carotid artery. The carotid artery. Now, the carotid artery, it is supplying blood to the brain. I'm coming back to it. Give me 1 second. And if there is a kid watching the show at this point, I'm going to ask the parents to sit with the child, because what I am going to say might need a little censoring. No kid should practice what I am about to say. On the right side of the neck is what we call the jugular vein. Persons who are well trained can manipulate these two blood vessels. I won't say how because kids might be watching. Can manipulate these two blood vessels and put you to sleep. Yeah, they can. I won't tell you how. If you want to find out how, send me a message and I will send it directly to you. So you can manipulate these two blood vessels. Remember, on the left, we have the carotid artery, and on the right, we have the jugular vein. All right? So carotid artery, jugular vein. Carotid artery, jugular vein. Now, the carotid artery is carrying blood to my brain, and my brain cannot do without blood for a very long time. If my brain is depleted of oxygen and blood, I will suffer from a condition called blue brain, which might render me to be a vegetable. Blessing, Sir Wilson. All right, Beric. Hi, how you doing? All right, good. So let us continue. This one, you have to get it right. Oh. All right, so let us go. So we spoke about, let me go again. So we spoke about the first one was, let me see if you're listening. What was the first organ we looked at? What was the first organ we looked at when we started out looking at these? Remember, we said that these are 5 organs that the syllabus wants us to look at. The first one was, just type the first one. That's all I want. The first one. Don't fall asleep on me now. Don't fall asleep on me now. Come on. Remember, we're talking now. We're talking about the brain, the intestine, the liver, the kidney, the lungs. All right. Very good. Adi's saying the lungs. So the first organ we spoke about was the lungs. Now, what are the 2 blood vessels associated with the lungs? What are they? Very quickly. Don't fall asleep on me now. The lungs, sir. Very good, Walker. All right, the lungs. What are the 2 blood vessels associated with the lungs? The 2 blood vessels associated with the lungs, we have been saying them over and over and over and over without any itch. 2 blood vessels associated with the lungs. All right, I take it that the internet is logging, so I'm going to give you a second question. What are the 2 blood vessels? Yes. What are the 2 blood vessels? I know that you might be having some problem coming across the water. All right. What are the 2 blood vessels that are associated with the kidney? So I want the 2 blood vessels associated with the lungs, the 2 blood vessels associated with the kidney, and now I need the 2 blood vessels that are associated with the brain. Those 2 blood vessels that I say you must make anybody and give you because it might cause a blood clot. And if you have a blood clot, you might end up with a stroke. All right. So I want to know what are the blood vessels that are associated with the lungs, what are the blood vessels that are associated with the kidney, what are the blood vessels that are associated with the brain. All right. Give me those. So we looked at kidney, lungs, brain. So we have liver and intestine left. It's carotid artery and jugular vein. All right. And those are associated with the brain. I think I'm having some lag here. I am getting a lot of complaint that persons are being kicked off I have no control. I'm very sorry. So it's a carotid artery and jugular vein. Those are associated with the brain. That's Amoy coming from outer Trinidad. I so like my Trinidadian and Guyanese, and tell you the Jamaicans are always here too. Big family. I like the cultural exchange. And at the end of the program, remember, we're going to have our cultural exchange where we talk about countries, the difference between my country, your country, that type of thing. One day we might just have a big celebration where everybody meet up for this class. All right, so here we go again. So that's it for the brain. Now, I'm in Jamaica. I am from Jamaica. All right, good. All right, so jugular. Let us continue. Who is from Trinidad? We had a Trinidadian here earlier. We had a Trinidadian here. All right, so let us continue. The lungs, it is the renal artery for the kidney. Renal, yes, renal artery, renal vein. And the lungs is going to be the pulmonary artery and, of course, the pulmonary vein. And Juliana Walker said the renal artery and the renal vein, those are for the kidney. Wonderful. We're doing well. I really want you to know these like a knock, kidney, renal artery, renal vein. Lungs, pulmonary artery, pulmonary vein. Brain, carotid artery, and jugular vein. I want you to know it like that. So now that we have done those three, you can write them down. The lungs, pulmonary artery, pulmonary vein. The kidney, renal artery, renal vein. The brain, carotid artery, jugular vein. And now we are going down to the intestine and the liver, where I promised you that you are going to be having a little challenge in remembering these. Now remember, the blood vessel supporting or taking blood to the liver is called the hepatic artery, right? And the blood vessel taking the blood away from the liver is called the hepatic vein. So you have the hepatic artery and the hepatic vein. The hepatic artery and the hepatic vein, they are associated with the liver. The hepatic artery and the hepatic vein, they are associated with the liver. And then we have now the intestine, the gut. The gut is a good word, And the gut, interestingly, it starts from our buccal cavity, which is the mouth, the buccal cavity, and it goes straight through to the anus, right? So we want to look at the blood vessel that is supplying the gut with blood and, of course, taking blood away from the gut or the intestine. Remember, we spoke about the mesenteric artery that takes blood to the gut or to the intestine, and then we are going to now have the hepatic portal vein. So remember, we spoke about the hepatic artery and the hepatic vein. Now we add something to that to say hepatic portal vein. Hepatic portal vein. Mesenteric artery. So the mesenteric artery, it is supplying blood to the intestine, while the hepatic portal vein is taking blood away from the intestine. And then we spoke about the hepatic artery and the hepatic vein. All right, we're doing good. So we would have covered everything: the liver, the intestine, the brain. If the internet service was a little faster, I'd definitely give you a quiz on this, but the service seems to be logging, and it's sort of killing the vibes in the class when I'm asking a question and no one is answering. Now, we started out by looking at the components of the circulatory system. And when we started, then we were saying that the components of the circulatory system, it is actually the heart, the blood vessel, and the blood. Now we're going to be looking at the components of the blood, and the components of the blood refer to those stuff that makes up the blood. And the blood is made up of really blood is really composed of three things. It's composed of red blood cell, white blood cell, platelets, and of course, We're going to talk about plasma as well. Now, the cells are suspended in fluid that we refer to as plasma. And of course, it makes up about 45% of the volume of the blood. Huh? All right, sorry about that. The cells will make up about 45% of the blood, and the plasma is going to make up about 55% of the blood. I really don't like this percentage stuff. I just know that the plasma is more than the blood cells. And remember that we have 3 blood cells that we are concerned about. Are 3 types of cell, because it's going to be 4. All right. By the time we're finished, though we talk about 3, when we're finished, we're going to end up with 4, because we're talking about the erectocyte, which is the red blood cell. Erectocyte. We're talking about the thrombocyte, which is the platelets. We're talking about the phagocyte, which is a very interesting one because it has a lobe nucleus. And we're talking about the lymphocyte, which is also interesting because it is bigger than the others. All right. So let us continue the exploit with the components of the blood. Now, plasma, one would know that plasma has this yellowish color, right? And one would ask, why is the blood red? The blood is red because of the hemoglobin, right? Now, the hemoglobin is that pigment. I like to talk about the hemoglobin is to the blood as the chlorophyll is to the leaf, right? So the hemoglobin causes the blood to be red. Now, the plasma, I learned this from probably grade 8 thereabout at high school, that the plasma is made of about 90% water, and the other 10% is, of course, dissolved substances. This whole lot of maths. So let me go with the maths again. So we're looking at blood. And we're saying that the blood contains about 45% of what we have in our body as blood. That is blood cell. And the blood cells are the 4 type of blood cell we talk about. And then now we say that the 55% that's left, that 55% is plasma. And we say that this plasma is a liquid, right? And it is made up of about 90% tighter water. And that is why the blood can flow like it flow. And then dissolve in this now, we have about 10% are dissolved substances. All right? Now, can anybody tell me in the chat there, what are the dissolved substances in the blood? What are these dissolved substances? The dissolved substances in the blood, what are they? The dissolved substances that are found in the blood? All right, the first thing I would think about is the product of digestion, because you're eating, and in order to have that energy, you definitely have to have some dissolved substance that's in the blood that is moving. So you have the dissolved substances from digestion, and you just did digestion, and you'll recall that the smallest part of starch is going to be glucose, and you're going to be having that in the blood. The smallest part of protein is going to be amino acid, and you're going to be having that in the blood. And you will remember from our class on Friday when we look at vitamins and mineral, you are going to be getting some of that from your fruits and your vegetable and all of that. So those also will be in the blood, the vitamin and, of course, mineral. Remember, when we looked at the vitamin, we said that the vitamins were those that are in letters, and when we looked at the mineral, they were more like those that were associated with the periodic table, magnesium and calcium and iodine, that type of thing. And that helped us to make to understand the difference between vitamins and mineral. It was an easy way to look at it. Now, water products. So all of these are, in most cases, they would have been soluble to water. But there's also what we refer to as waste product in the blood. There's waste product in the blood. And we have been talking about this oxygen and carbon dioxide as it relates to the blood moving around the body, oxygenated and deoxygenated. We are going to be having some carbon dioxide as hydrocarbonate in the blood that is been moved also as a substance dissolved in the blood. And you will recall that hormone is in the blood. So we have a list here that comes from the syllabus, that the syllabus wanted to look at some material that need to be transported in the blood. And these, of course, would have been some of the dissolved substances. We have oxygen, we have carbon dioxide, we have hormones, we have minerals. These are things that you should know. I tend to take them from the syllabus, that you don't just go about and just write down anything. You know exactly what you should know. You should know that oxygen is transported by the blood in a dissolved form. You should know that carbon dioxide is transported by the blood. You should know that hormones are transported by the blood, and hormones are actually protein. You should know that. All right, you should know about the minerals as well, that they are transported, and you should know about glucose and amino acid. So look here, you don't need to go all over the place and study and know everything that there is to know in biology. You're studying for an exam. So you follow the syllabus and you know what you should know. So I have written the things from the syllabus here on my guide for the day. I have to look at the guide every now and then to ensure that I'm not telling you what you don't need to know. All right, so there are other things. Remember that it is dealing with carrying food substances, and it's also removing waste product. Of course, the plasma main function is transporting these materials. Some are waste, urea. It transports heat as well. All right, plasma is transporting heat, keeping the body warm and all of that. And the hormone, you know that hormones are actually chemical messengers. They tend to act much slower than the nerve cells do, but they do carry messages for the body. Messages like the quickest one can remember is usually fight and flight hormone, which is, of course, the adrenaline. But you have thyroxine and you have many other hormones, and these are actually chemical messengers that are carried in the blood. Then we have urea from the liver to, of course, the kidney. And carbon dioxide, we have said that a million times. So the components of the blood that we need to know that is transported, we need to know about the blood cells, right? We need to know about the blood cells. And if I were studying like you, I'd just write some of these things on a folded piece of paper like this, and just probably just write at the top components of the blood that I should know. And I'd write first ones. I remember I try to make them be practical. So oxygen, carbon dioxide is sort of practical. Then I come to my mouth, food, and I'll probably think that I'm sweating. So I think about urea, I think about all of these things have must be moved in the blood. I think about the glucose, the amino acid, that type of thing. So remember, let me just give you them: oxygen, carbon dioxide, hormones, glucose, and of course amino acid. And you remember your vitamin and minerals. Those need to be transported as well. All right. So you see, there's not much to know about the components of the blood to be transported. It is very important that when you're studying, you're following what is on the syllabus. I continue to say that. Don't just go and buy a book and just read it from start to finish, and then you say, oh, I read a book from start to finish and I fail. You are studying for an exam. You're not studying so much for biology, because biology is bigger than a little exam that you'll be doing. All right. So you're studying for that exam. We're going to be looking at the blood cells now. And remember that you'll have to do some more reading. I'm going to be putting out some videos on these, but you'll have to do some more reading. I'm trying to speed this thing up. So we want to look at the blood cells. And I know a lot of you like to talk about big word. Sir, them word are too big. Erythrocyte, thrombocyte, leukocyte, lymphocyte, granulocyte. You're afraid of these words. Guys, you got to know them for the exam. You must know them for the exam. So we're going to start by talking about the red blood cell. And as it were, for these blood cells, you must know, you must be able to describe them, you must be able to draw them, you must be able to identify them, you must be able to tell how their structural makeup make them suitable for their function. So we could look at the red blood cell, which is called the erythrocyte. The red blood cell is called the erythrocyte. And the red blood cell, in most cases, when it is drawn on an exam paper, you are going to see like two cells beside each other. You are going to see a round, and then you are going to see one looking like it's sideways something. And you're going to see these two, like a little eight somewhat sinking, two cells beside each other. and you are going to know that that is your red blood cell. Now, the red blood cell are considered to be biconcave. This, what it means is that it has a depression in the middle. Now, that makes the red blood cell suitable for its function because it increases the surface area of the red blood cell. Now, somebody is confused, but we just said that human surface area to volume ratio. We're talking about human then. Now, we're talking about a cell, and the red blood cell is as small as probably the amoeba, same type of one cell thing we're talking about. So, the depression in the center of the red blood cell allows it to pick up oxygen very, very quickly, allow gaseous exchange to take place very quickly. Now, another thing that we need to know about the red blood cell does not have a nucleus, and they live for about 3 to 4 weeks, about 3 to 4 weeks. All right, I think it's a thrombocyte lasts for days. All right, so what we need to remember is that the red blood cell, they don't have a nucleus. The red blood cell, they are transporting oxygen. The red blood cell, they transport small amount of carbon dioxide. And we also need to remember that the red blood cell, they are made in the bone marrow. I like to say the bone marrow. The books might tell you that they are made in the long bone, or 3 to 4 months. I'm very happy that somebody is following. So the red blood cell, they will last 3 to 4 months, depending if all is healthy. They could last much less than that. They could last 3 to 4 weeks, but they will go up to 3 to 4 months. All right, let us continue with that now. The red blood cell, they are made in the bone marrow. Now, some books might tell you that it's made in the long bone. Some books might tell you that it's made in the flat bone. Some books might tell you that it's made in both. But what we know is that the blood cell, they are made in the bone marrow. And I like to say, like, all the blood cells are made in the bone marrow. All right. The red blood cell, they are broken down mainly in the liver and the spleen. But their chief function is supposed to transport oxygen, and this oxygen combines with hemoglobin to form what we refer to as oxyhemoglobin. Just let me pause a little bit here to just to add a little bit to the red blood cell, being that we're looking at the red blood cell. When we have carbon monoxide poisoning, carbon monoxide is carbon monoxide, one oxygen. What happens is that, oh, please slow down, sir. I am going too fast. I'm very sorry. So I'm going to start asking some questions. It happens like that sometimes. All right, I'm going too fast, so let me just go back a little bit. So we're looking at the red blood cell. The red blood cell is called the erythrocyte. And the red blood cell is a cell that everybody would know. Me get a cut out my blood. And in most cases, we are calling the blood cell. Now, remember that the blood is a mixture that contains different types of blood cell. So while you might see the blood being red because of the hemoglobin, in that same blood, you have the white blood cells and the thrombocytes as well. Now, we started by looking at the red blood cell, and we're saying that it's specially suited for its function because it is a biconcave disc, which increases the surface area of the red blood cell, allowing it to pick up this oxygen very easily. Now, we also said that the red blood cell transports some amount of carbon dioxide as well. We continued by saying that the red blood cell, it doesn't live for very long, and you could not use the red blood cell. John, no, sir. The Wi-Fi move away. Yeah, that's true. We continued by saying, no, I was about to tell you this. Sorry. I was saying to you that you cannot produce a clone of an individual using the red blood cell because the red blood cell has no nucleus, hence it has no genetic information. Now, it's very important to know, let me get back to this carbon monoxide poisoning. With the carbon monoxide, when light, you have no electricity and you turn on that generator, turn on the car in the garage, and then you can't wake in the morning, you're dead. What happens is that the carbon monoxide tend to attach itself easier to the hemoglobin than does oxygen. As such, the body becomes depleted of oxygen and you end up being poisoned by carbon monoxide. So it's very, very important for you to know that carbon monoxide is odorless, tasteless gas that can kill you. All right. Another thing that you need to know about the red blood cell is that the red blood cell, of all the blood cell that we are talking about now, they are in the largest number. And when we say largest number, there are hundreds of red blood cell to one white blood cell. Hundreds of red blood cell to one white blood cell. So remember, the endowing understanding is that the red blood cell is made in the bone marrow, flat bone, and at the end of the long bone. Other thing that we need to know about the red blood cell is that its chief function is supposed to carry oxygen to the cell, and of course, it removes carbon dioxide from the body cells, and of course, it takes it to the lungs. And you would have seen that in the video I posted today. Another takeaway is that the red blood cell can live for about 3 to 4 months. However, you might find it living for 3 to 4 weeks, depending on your health condition. Uh, we're going to be moving on now to the other types of blood cells. There are two main types of white blood cells, and we are going to be looking at the two main types very quickly. And I want to just make a comparison between the lymphocyte and the phagocyte. Now, let me tell you something very easy. I can use the street language. The phagocytes are the eater. They are always eating. They eat, eat, eat. All right. So the phagocytes, they are the eaters. Now, the phagocyte feed by what we call phagocytosis. And if you ever heard about phagocytosis, it means that you were listening to my video with the amoeba when we looked at microbes. Many persons didn't watch those videos, but I did cover it there. Now, I want to talk about this one because I really love the granular site, and I'm going to be drawing it on a paper right now. I'm going to be showing you that cell. I didn't do such a good job of the red blood cell now, but I am going to be doing a perfect job of the granular site. It's called granular site, or it's also called phagocyte. All right, and it feeds by what we call phagocytosis. All right. So usually when it is drawn, in some cases, one thing you need to remember about a blood cell is it's an animal cell, so the shape can change at any time. So don't go studying and say, this is how it is looking at my books. That's how should I look at the exam. No, don't do that. All right. So this is the white blood cell I'm talking about now. It has what we call a lobe nucleus. All right. So once this is the one we call the phagocyte. It's called phagocyte or granular site. And it's called granular site because it tends to have that appearance in most cases, like it has some granule in it. Right? It looks like it has some granules in it. Now, this here are the pathogen that it is feeding on. All right. And what phagocytosis means, it doesn't have a real mouth. What it will do, it will just cover around the body, will just cover up around, and the membrane just break and close back, and then it digests it on the inside here. All right. And then this organism moves. It doesn't have a leg to walk. It doesn't have a flagellum. It doesn't have cilia, but it has what is called pseudopodia. Now, pseudopodia are false leg. And like when we talk about pseudopodia, if you watch my video on the microbes, when I spoke about the amoeba, you would have known about the pseudopodia. So we'd say that it does what we call cytoplasmic streaming. What that means, like if water throw on the ground and you see like the water running on the ground, that type of way the organism move. It doesn't have a real leg, so it just move the membrane and move pretty much like water thrown away on the floor. All right. So we're looking at the numbers. We started out by saying that there are more phagocyte than lymphocyte. And I'm going to be giving you practical examples that are probably not in your textbook. You understand right away, I have said it clearly. The phagocytes are the eaters. The white blood cell, they are protecting you from foreign organism. When we say foreign organism, we're not only talking about COVID will come from foreign. We're talking about anything that does not belong inside of the body. All right. So the white blood cells, they are actually protecting you from foreign or invading organism or disease-causing organism. Now, there are way more phagocytes than there are lymphocytes. Now, the lymphocyte, I'm going to be talking about that by itself, but it is a very big cell with a nucleus. Now, what you find happening is that the phagocyte and the lymphocyte, they both have nucleus. However, the erectocyte, which is the red blood cell, does not have a nucleus. Now, I don't want you to go about mixing up these words, lymphocyte and leukocyte. Now, leukocyte is the general term that we use to refer to the white blood cell. But when we talk about leukocyte, under leukocyte, you are going to have lymphocyte and phagocyte. I was just remembering an analogy I usually use. So when I teach this lesson in my cartoon framework, when I go into my own cartoon framework, this is what I say. You got a cut or something like that, and vitamin, the thrombocyte should have helped to form a clot, and it's going to form the clot with the aid of calcium and vitamin K. But there are foreign invaders there. What is going to happen is that the phagocytes are going to seep through those cell wall and get to that area. When it gets to that area, they are going to do the eating. They are just eating up the pathogen, eating. They like to eat. The phagocytes, they like to eat. They are eating. But while they're eating, it's just more than they can eat. It's probably like KFC. You can't finish all the chicken down KFC. So the phagocytes, they are just eating. Now, they are eating, and despite their eating, the pathogen is just multiplying. They can't manage it. So what they do in my cartoon world, they would probably just take out their phone and they would like, a ring. Oh yeah, I can talk to lymphocyte. Hey, yeah, lymphocyte, what's happening? You know that I'm down here and I'm having some problem with some pathogen. I need some help. And then the lymphocyte is going to come in like the American Air Force with airstrike. Boom, boom, boom. And it's just going to drop some chemicals in the area that will deal with that. I'm going to be telling you about the chemicals shortly. I hope I didn't disturb you. I hope you don't think that I'm a madman. All right, here we go. So the phagocyte, they have different shape. You can find them in many different shape. We spoke about pseudopodia already, and we spoke about they have what is called a lobe nucleus. They are formed also in the bone marrow, and their chief purpose is to engulf. No connection. Their main purpose is to engulf and destroy pathogen. All right. And what we mean engulf, they are eating pathogen and destroying pathogen, protecting the body. All right. No connection. I don't know what's happening. This is saying no connection. All right. Anyway, let's go. I hope that I have not lost anyone. All right. So we are going to up on over now to the lymphocyte and then the platelets, and that's going to be our final thing for the evening. Now, the lymphocyte, they are somewhat circular in shape, somewhat like that, and they are in, of course, they have a big round nucleus. There are times when you will mistake the lymphocyte for the ovum. There are times when you will mistake the lymphocyte for the ovum. And they, of course, have just a little bit of cytoplasm. All right, where are they found? They are actually made in the red bone marrow. And however, they tend to mature in other organs like the lymph and spleen and all of that. All right, so their purpose we spoke about, we call them just now, to come in the area and release some chemicals. They are going to produce antibodies to destroy the disease. So those that the phagocyte could not have eaten, the lymphocyte is going to release antibodies. It's like a chemical warfare to destroy them. Now they'll also produce antibody to neutralize the toxin that is produced by these foreign organisms. So the white blood cell is always protecting you from danger. The phagocytes, it is doing the eating, while the lymphocyte is doing the chemical warfare, where they are releasing these antibodies to kill the pathogen or to neutralize the toxic effect or toxic chemical they would have released in the organism. Then we have the last one we want to look at for the evening. We want to look at the platelets, which are also called thrombocytes. They are usually said to be cell fragment, and they really don't live for very long. They too are made in the red bone marrow, and they help the blood to clot. Now, they help the blood to clot, and in doing so, partnering with thrombocyte, you are going to have vitamin K and you're going to have calcium. Now, this is going to take us to the end of a content that is scheduled to be presented today. We are going to be looking next week. I'm going to be putting out 2 videos. I'm going to be putting out a video for systole and diastole to show you the animation. I'm going to be putting out a video for this blood clotting mechanism. I'm going to be showing you those 2 videos. I'm going to be working on them. That takes us to the end of the class, and we're going to have our recap very quickly. I'll be asking you a question. I do hope that you're online, because one of my system here is telling me that there is no connectivity. I'm hoping that I'm not talking to just myself. So I'm going to be asking some questions now, read the lesson, and then we are going to be breaking out into our social interaction, our cultural exchange. If you are not from Jamaica, could you just type your name in the chat? Could you just type your country in the chat? So we've been having persons from Guyana, we've been having persons from Trinidad. We want to talk to you, we want to share our Jamaica with you, and we want you to share your nice island with us. We want to come there someday for a vacation. All right, so let us begin with the recap. In today's lesson, we looked at blood vessels, and we looked at some blood vessels that are supplying and taking away blood from some major organs. We also looked at the components of the blood and components of the circulatory system. Now, we looked at some blood vessels and the differences between the blood vessels. We did look at that as well. Now we want to recap and see how much we can recall from what we have done. Now, I am going to be taking the first set of answers from the 5 organs we looked at. All right? But before I take it from the 5 organs I looked at, I want to touch, the earphone is squeezing my ears. I want to touch one thing that I put out in the video yesterday, that my HSB kids won't kill me. My grade 11 HSB kids, I don't want you to have my throat, because you're saying that I am not doing HSB, which is not true. I cover both syllabus, but I'm so good at it that I am able to find the two content and mix them. All right. So I want to talk a little bit about the pacemaker. And I spoke a little bit about it earlier, but I'm going to talk about it again. Your syllabus wants you to know about the pacemaker, as in the one that is inside, and it wants you to know about the natural, about the artificial. So the pacemaker is usually located, or it is located to the top right atrium. What it does, there are some specialized cells there that they fire some electrical impulse that stimulate the heart to contract. And the heart has been doing this for quite some time, and it just never gets tired. And it never gets tired because it's made of these specialized muscles, cells called cardiac muscle cells. So the heart is made of cardiac muscle, and the syllabus wants you to know that it is made of cardiac. The pacemaker helps the heart to beat very well. Now, there are times when the pacemaker might go bad. And when this happens, this is what happens. Listen, guys, you might suffer from if you have a heart attack, you might need a pacemaker. If your heart have irregular beats, you might need a pacemaker. If your heart is beating too slow, you will need a pacemaker. And you are going to appreciate this, because if a heart is beating too slow, it means that the gaseous exchange process is also going to be slow, because it means that the blood will be moving through the body very, very slow. Now, when the pacemaker is not working and you have all these problems with the heart, you need an artificial pacemaker. And an artificial pacemaker is nothing but a battery-operated device, mechanical device, with wires that is usually installed under the skin, and the leads are the wires connected to the heart, and it fires just about the same impulse to get the heart working. Now, everyone would love to have a pacemaker if you have a heart defect, because you really don't want to die. No one wants to die. Everybody wants to live forever. So it's very important that you understand the pacemaker. If you listen to my videos, you always hear me use these words, very important. If I say it's very important, there's no buffer there. What I'm telling you is what you need to know. All right. So remember, let's start from the neck going down now. We're going to be looking at the blood vessels associated with the particular area of the body that the syllabus asks us to look at. So we're going to start with the brain. What's the name of the artery taking blood to the brain? Very quickly for me. What's the name of an artery taking blood to the brain? The name of an artery taking blood to the brain and the name of an artery taking blood from the brain. Could you write that in the chat for me very quickly? So I want to know the name of an artery that is taking blood to the brain, and I also want to know the name of the blood vessel that is taking blood away from the brain. All right. Please type. I'm observing what is happening, and I'm going to be treating with that in a short while. I did put out a video that should correct that answer that Sanada gave just now. That video came out today about 12 o'clock, where I looked at the heart as a double circulation. And it's a new animation I did for that. You know, I'm putting out a whole lot of animation now because I want to get to that. Don't answer the question yet. Guys, don't answer the question yet. I really want to treat with this. I sent out a video today that looks at pulmonary circulation. That is circulation. As it's a pulmonary, it has to do with the lungs. So it has to do with blood leaving the right ventricle, upward through the pulmonary artery, to the lungs, pulmonary vein, and back to the left atrium. That's pulmonary circulation. Now, the diagram that you would have seen in your textbook shows the lungs above the heart. And then the systemic circulation, it's from the left ventricle to the rest of the body, and it comes around via the vena cava and come back to the right atrium. I did say in that video, at no point you should allow yourself to be confused to think that the head is a part of the pulmonary circulation. The head is still a part of the body that is grouped or classified under systemic circulation. We are looking for those two blood vessels. You can answer now. They are right here. That supply the brain with blood and take blood away from the brain. We did cover it in class today. I also want you to tell me, good, Juliana Walker, carotid arteries, sir. But carotid artery, I asked for the blood vessel that is taking it to and from, to the brain and from the brain. All right? To the brain and from the brain. I also want the blood vessel that is taking blood to the kidney and away from the kidney. Huh? All right. So, Amoy Lawrence, could carotid artery and jugular vein. So the carotid artery is carrying oxygenated blood to the brain, while the jugular vein is carrying blood away from the brain. Now, the kidney, what are those blood vessels that are associated with the kidney? Blood vessels associated with the kidney. What are the blood vessels associated with the kidney? Or kidney, the renal vein and the renal artery. Okay, so now there is a jugular vein. Okay, that was for that one. Very good. Now, those two answers are correct. So we are now going to be looking at the lungs. What are those two blood vessels that are associated with the lungs? These are things that we should know from the brain. You know, just pull them out of your brain very quickly. All right, the blood vessels that are associated with the lungs. I did all already. Lungs, I haven't done kidney. I did kidney, brain. All right, the lungs, amari larynx, pulmonary vein. All right, so um, amari larynx is saying pulmonary vein, pulmonary artery. Those are associated with the lungs. Sonada is saying pulmonary artery, pulmonary vein. Those are also the same answer associated with the lungs. Now we want to look at the blood vessels that are associated with the intestine. Remember that I said that these were the tricky one. All right. So the blood vessel that is associated with the intestine, taking blood to the intestine, I want to know that. And I want to know the blood vessels that are taking blood away from the intestine. I want you to also tell me about the liver, the blood vessels that are associated with the liver. Remember, these are stuff that are required by the syllabus, which means that you need to know them. You're going to jot them down on your white paper. Remember, we spoke about white paper. Jot them down on your white paper and make sure that you know them, that you can dispose of a white paper. So, the hepatic something, amari larynx, the hepatic something. The hepatic something is for what? All right, so we have the mesenteric artery that is taking blood to the mesenteric artery is taking blood to what? The mesenteric artery, hepatic portal vein. Those are going to be associated with the intestine. Now, the hepatic something is for the liver. Now, it is going to be the hepatic artery and the hepatic vein. Now, the intestine just gets the portal in it there. All right, so that's it for the blood vessels. Now, we looked at the artery, we looked at the vein, and we looked at the capillaries. Now, we made mention of the venules and so on. Now, what I want you to tell me, which blood vessel has a valve? Which blood vessel has a valve? Very quickly. Which blood vessel has a valve? The thing is really logging. See some answers just coming in. It's really going slow. All right, so which blood vessel has a valve? All right, there are three answers in. These three persons, four answers. These four persons are saying vein. Which blood vessel has a valve? And it's the vein. And always remember that the vein, of course, stops the backflow of blood. Now, let me tell you something about the vein before we leave the vein. I did not say this in the lesson. I might have said it in a video yesterday. Now, the vein, if these valves become weak, remember, look at my screen. I'm going to be showing you something. If these valves become weak, what will happen is that you will have backflow of blood. So the valves are pretty much V-shaped like this, where the blood would be flowing upward like that. Now, if these valves become weak and they are not closing, the blood will flow backward. All right? I wouldn't go as it should. And in this case, the person will suffer from what we call, if it's in the leg, they call it varicose vein. We are seeing these blood vessels behind the leg, behind the knee area there, sometime or below. Some big dark veins come up because the valves are weak. In that case, you have to use a sleeve on your leg to ensure that you can help to close them. All right, persons who usually suffer from varicose vein or weakened valve in the vein, persons who stand long, teachers, doctors, nurse. So I want to go work on it, sit down. Yeah. All right. So another thing we want to look at, we want to find out which blood vessels would have blood under low pressure. Blood under low pressure. Which of the blood vessels would have blood under low pressure? Low pressure. Vessels. I made it easy for you. Vessels. All right, keep going. I'm looking at your answer. So I have capillary so far, and I have vein. They would have blood under low pressure. Thank you very much. That's going well. Which blood vessel is 1 cell thick? This eyeglass is not good. Which blood vessel is 1 cell thick? 1 cell, single cell. Boop, boop, boop. Capillaries. Any other answer? All right, capillaries. I'll go with capillaries. Thank you. You're doing well. Which blood vessel has blood under high pressure? High pressure. Blood vessel with blood that's under high pressure. Artery. Is there any other answer? High pressure. Arteries. All right, very good, guys. You're doing what? You're really doing awesome. Tell you, you're really doing great. Really doing great. Really doing great. And I do hope that you are going to study. You're going to do those practice questions for those persons who I have recommended text for. You're going to do the practice questions in the textbook. I do hope that you're going to study for the others. Now, I'm going to be asking you which blood cell is responsible for transporting oxygen and carbon dioxide. Which blood cell? Blood cell responsible for the transportation of oxygen, and it takes some amount of carbon dioxide. Somebody saying the red blood cell. Is there any other answer? So the red blood cell is going to be the erectocyte. Bartender vein. Oh, they call it that as well. That's a varicose vein. It's called bartender vein. Bartenders are usually standing. That is possible. I don't know. It is possible. All right. So that answer is coming in. I'm not too sure if that answer is late. Capillaries. That was the answer we're looking for. Blood vessel that has blood under high pressure. This blood vessel is deep into the skin. Deep into the skin in order to protect you. That's going to be the artery. The blood vessel that carries both oxygenated and deoxygenated blood. Which blood vessel is that? Blood vessel that carries oxygenated and deoxygenated blood. Oh, I'll get back to blood vessels. I'm talking about blood cells. All right. Answer that for the blood vessels. All right. It's logging. That is why I think I am going back, because I'm seeing that type of thing on the screen. I'm going to go now to our cells. All right. The blood cell that would be first on the scene if you have a wound, which would it be? Would it be the phagocyte or would it be the lymphocyte? Phagocyte or lymphocyte? Which one is going to turn up first? Phagocyte, you got a cut. Which one is going to be there first? The phagocyte or the lymphocyte? You got a cut. Which is going to be there first, phagocyte or lymphocyte? You got a cut, and I want to know which blood cell is. Somebody saying lymphocyte. Lawrence is saying lymphocyte. Anybody else? You got a cut. Which of the blood cell that protects the body is going to turn up first? Will it be phagocyte or lymphocyte? Everybody is saying lymphocyte. All right, I don't want this to propagate. Let us get to it. The first person who is going to turn up is the eater. First person that is going to turn up is going to be the eater. And they are larger. We have a larger number of phagocytes. So they are going to turn up to do the eating, the phagocyte. They are going to turn up to do the eating. And remember, if they can't eat off everything, then they are going to be calling the lymphocyte. Remember, the first person on the scene is going to be the phagocyte to deal with the eating. If he can't eat up everything, then I'm going to call the lymphocyte to release antibodies that will either neutralize toxin or will kill pathogen. All right? Now, the blood cell that is associated with blood clotting, Which blood cell is that? The blood cell that is associated with blood clotting. It helps the blood to clot. What's the name of that blood cell? Amoy Lawrence is saying platelets. Any other answer? Walker is saying platelets. Helps the blood to clot. Any other answer? All right, platelet is correct. Now I want you to name two nutrients. I want you to name a vitamin and a mineral that is associated with blood clotting. I want a vitamin and a mineral that is associated with blood clotting. A vitamin and a mineral that is associated with blood clotting. I gave them earlier in the lesson. Iron aid with the production of blood. All right. Vitamin and mineral. Oh my works. I will have to have a class on digestion. Amino acid and glucose. Iron. We'll get into digestion shortly because we're doing nutrition now. So I'm going to take you guys to task when I get there. All right. Remember, it's going to be vitamin K and calcium. Calcium is the mineral and K is the vitamin. Guys, we want to remember that as we go along. Now, tell me the components that are the substances that are transported by the blood. I think we're going to have a wrap on that. Substances transported by the blood. That's where we are now. Substances that are transported by the blood. I remember I gave you some that the syllabus asks. So when it comes to me, the syllabus is my Bible. So I don't try to play like I am bright. I try to ensure that I am getting what the syllabus is asking for. As such, with every show that I have a script for my show that I follow the guide as to what it's supposed to cover and what the syllabus needs. All right? So hormones, which are protein, eat, of course. And we could probably jump on up the top to amino acid and glucose that came early. Urea need to be removed as well. All right, a vitamin and mineral, they are transported as well. Carbon dioxide and oxygen. Now, thank you very much. We are at the final stage of the show. We actually are over time with the show. We are now supposed to do our cultural interaction. Do we have anybody in the room now that is not in Jamaica? Yes or no? Cultural interaction is very, very important for us. Do we have anybody in the room that is not from Jamaica? Could you say yes? And let's have our session on cultural interaction. Is there anybody in the room that is not from Jamaica? If you are not from Jamaica, we want to hear from you. Thank you very much for joining the show this evening. There is a request for us to have a midweek show that we're going to be, yes, sir, lol. There is a request for us to have a midweek show that we're going to be looking at ecology. We continue to put out videos weekly. We have a video out yesterday on the passage of blood through the heart. We have a video out today that looks at double circulation, which is the pulmonary and the systemic circulation. We are going to be putting out a video on systole and the diastole, and of course the blood clotting. Now, somebody's asking what time is the show on Wednesday? The time for the show on Wednesday? 5 still? All right, we are going to try to go for 5, the show on Wednesday. Wednesday show is, I think it's going to be a little easier. I am a trained environmentalist, like I am a trained agriculturalist. So I'll tell you that Wednesday show is more like the show that we had on plant nutrients, where a whole lot of recall and a whole lot of definitions and so on. Of course, I'll be doing some simulation for the labs. So, of course, it's going to be easy. You have to prepare for the show, though. You have to prepare for the show. I really don't want to come to the show in person, so I just seated and falling asleep on me. I really don't like that. I remember I am going to be asking you past paper questions come next week. This week I got you off guard and you were not prepared to answer those questions. They were a little big for you. Even though they were content that we covered, they were a little big for you. So I'm going to ask you to study, because next week I'm going to add another year past paper to it, and you're going to look at what we have covered in circulation. I'm going to just look for all the circulation questions, not all, just about probably no more than 10 that we can answer surrounding circulation. In our class next week Sunday, we are going to be looking at blood group. You really want to be there when I do that. We are going to be looking at the ABO blood group, which can be divided into 4 groups: A, B, AB, and O. And we're going to be looking at the rhesus factor, which can be divided into 2 groups, which is, of course, rhesus positive and rhesus negative. Now, why I want you to be here, this class is going to be a loaded class, and this is one of the classes that falls in the null curriculum. It's going to be a loaded class, and I'm going to share a lot of experience with you. One, I can say to you, this blood group thing is very important, because if you have blood group O as the mother and the child has A or B blood group when the child born, the child most likely will suffer from jaundice. As the child suffers from jaundice, the child might also have a reduction in the number of white blood cells. So these things you need to know. There are some women who have who are challenged getting pregnant because of the rhesus factor. So we want to look at that. Then we are going to up on over, and I think we are going to be looking at systole and diastole. We're going to be looking at blood clotting, and we are going to be looking at immunology. How do we gain immunity? That type of thing. I ask that you read for that session. It won't be a walk in the park. Those topics are not walk in the park. Those things are things that persons really don't talk about. But can I tell you, the blood group is always on the paper. Can I tell you, sir, I want to know that thing in the neck that can make people sleep. I spoke about it today. I watch wrestling. I spoke about it today. All right, let me just make it very easy for you. If you deprive the brain of oxygen, you will fall asleep. That much I can say. So I was saying that the class next week is not a walk in the park. It is going to be the last class that we're going to have on circulation in animals, after which the week which follow, we are going to be looking at transport in plants. We are going to be looking at the xylem and the phloem and transpiration and all of that. All right. I'm going to look at it. I might ask you to do some simple lab at home so that we can have a conversation. HSB, there are some things that I have to put in your lesson for next week as well. I have to look at the capillary bed. I didn't look today at serum. I have to look at serum, and I will revisit plasma with you next week. All right. So we did a lot today. Thank you very much for coming. It is always my pleasure having you. I do hope that we are learning. Remember, this is not a paid session. This is a volunteered session. So I want to ensure that it is not going to waste. Please be reminded to subscribe, to like, to share, and when you subscribe, hit that notification bell. I like when persons subscribe, I can at least send them a message to say thanks. Watch the video, and when you are watching the video, watch the video to the end. You don't have to sit around the videos. The videos, it has audio, it has text. When I started out, I was taking in consideration those persons who are visually impaired. Those persons would be able to hear what I am saying. Those persons who have the audio problem, who can't hear, they would be able to read the content on the screen. And that is the whole reason for me doing the videos like that. For the live, if you have to read the live, you can turn on the closed caption on YouTube. It's right at the bottom of the screen there, to the right hand side of your screen. Turn on the closed caption for those persons who are having problem with the diction. I know that as Jamaican, we sort of talk a little different. If I know that you are not from Jamaica and you're in the room or you're watching, and then we try to make it where you can understand. But for most cases, we try to cut this thing so that persons from the Caribbean can understand. I'm very, very happy to have you. I hope that you are on top of things. I saw something coming out new about tablets in school, some document to be filled out. If you don't have an electronic gadget, or you know somebody that doesn't have an electronic gadget, just see if these persons would be qualified for this program, as I'd love to have everybody attached to the education system. Now, if we think that education is expensive, try the cost of ignorance. Please invite your friends to come on over. Invite persons to log on. We need to get to 1,000 subscribers. We need to get to 4,000 watch hours. Now we are almost there for the subscriber, but the watch hour, you're not watching the video. I have over 60 odd videos and you're not watching the videos to the end. Now, if you want me to keep going, you have to support the videos. Watch the videos to the end, share, and let us continue to build. It takes money to care, and you understand that we have to make the thing a little better as we go along. Remember, we started out, I don't know if you've ever watched my first videos, what it was like, or you watch my first live, what it was like. We kept improving. We are improving. Now we have animation to the thing. All of those art topic in 6C, we are going to animate them, right? I don't know that many persons are doing animation, but we understand that kids are not understanding a lot of things, so we do the animation. We sent out a video on autotrophic organism, and we'd asked for some feedback on the video, and it has some audio, and I doubt it has any talking. It is not the completed lesson. It was the first graphic animation that we were doing like that, and as such, we sent it out to get feedback from persons as to what we should put in and take out and all of that. Persons sent back, and there was some nice critique. So we are working on that because it takes so much. It's so much graphic, and it's a big thing. I'm working on it, and it should be out shortly. But since then, I think we have put out 2 other videos, and with this animation through the art, that's a big one. And like we say, we are going to be doing others. I think I did one today with respiration, with the diaphragm going up and down. I'm working on that. It's just that it's giving me a little problem in that it is jerking each time the person breathes. So that I have to correct, and as soon as I correct it, it will be out. Do you have any questions for me? Do you have any questions for me? Is there anything that I need to answer before I go? Is there anything for me to answer before I go? Remember, we're still going to be having classes in December. I am going to be putting you on a diet of past paper and study. And when I say past paper, I'm not asking you to go and work in the past paper by yourself. No, I'm not doing that. I'm going to be asking you to watch those past paper which are worked out and explained. And then when it gets to the time for you to do the past paper by yourself, I will tell you. But you're not there yet. All right? Don't bite off more than you can chew and then kill yourself. All right. Thank you very much for stopping by. I always like being with you, and every Sunday evening I'm with you. I really don't want to leave. Friday evening, I don't want to leave. But good friends have to part at some point. I will see you on Wednesday at 5, where we are going to be doing ecology so that we can finish the syllabus on time. I have one other very important video, or 2 other very important video where labs are concerned. I'm supposed to be sending out a PD video, planning and design video, how to write up your planning and design. And of course, I'm going to be writing up one for you and giving you the guideline for planning and design. And then there's a final one with implementation of that planning and design. But the implementation is in the back of the syllabus. So you need to just view the syllabus, go to the back of the syllabus for the implementation. Guys, we should be doing lab. Let us not get in this mood that when we go back to school, we'll be doing the lab. The labs can be done online, many of them. The only lab that can't be done online is measurement and manipulation. All the other labs, you can get them and do them. If you check my lab on variation, you will see the schedule for labs. I have placed them there. And if you need guide, whether you're a teacher or a student and you don't have any idea what you can do online, just send me something in the chat and I will tell you. The syllabus has 42 labs, and it is impossible that of 42 labs you are required to do probably about 18, of which 8 will be marked. And if of 42 you can't find some to do online, something is wrong. I am willing to help you. Persons doing HSB, your labs is in Appendix 2, and it's pretty much the same set of labs that bio students will be doing, except for the one for CXC. The one for CXC is like environmental science, and that you will require some amount of help. I will be here, I'll be assisting, I'll be doing one and posting it online so that you can have a good idea of what is to be done. However, in the new syllabus, there is a specimen for the lab. So persons who are doing HSB for 2022, go and get the syllabus. I can send you the syllabus if you want, or you can find it online. You are going to be doing a SBA. For the persons who are doing biology and the adult learners, I have labs online. Watch the labs. They will help you. It is the labs that are in the back of the syllabus that they are going to assist you on the paper 2. See you Wednesday. Ta-ta.